handful of fiber channel disks sitting there. Disk craps out. Part of my Z pool, but my Z pool is redundant, so service is still up. I pull the drive out. I put a new drive into the slot. If the auto replace property is set, ZFS will detect through the sysevent framework that a new disk was plugged into this slot, and this disk is in the same controller, target, blah blah blah, as previous disks that I owned and controlled that I marked as faulted, and therefore my policy is to auto replace, and it will automatically label the disk and bring it back on. So the goal then is that I can make an appliance where you can just walk up to it, stuff in a new disk, and the magic happens automatically. Okay. So that's the mom and apple pie picture. As a seasoned system administrator, those things scare the hell out of me in the general sense. And if they scare the hell out of you in the general sense, auto replace is off by default. Okay? Because again, it's going off and doing things to the disk that maybe people don't expect. And so by default it is off, but you can set it as on, and in those cases it should work. I'll put one caveat around that, and that is I don't know how it's going to work with worldwide numbers changing. It may not be as automatic as I would like. So that's something, particularly in the V80 where we have fiber channel disks there. For a regular SCSI SAS environment, it should do the right thing right out of the box. The fiber channel.
What about if you don't have any disk replacements, but you swap out an HVA, for example? How would that relate?
If I swap out an HVA, multipathing, in theory, gets us around that. Now, multipathing originally came out for fiber channel, and so there's a really irritating thing. Anybody who's used multipathing? NPXIO, yeah.
Well, DMP.
Or DMP is actually a little bit less obnoxious than you'll hear us call it NPXIO, multiplexed IO. I think the official thing is Solaris multi-target software. It's either SNTS or STMS. STMS.
Or traffic manager.
Traffic manager. Solaris traffic manager software. We call it NPXO because that was the engineering working name. And we're engineers, so we tend to remember things better than the marketing names, because I'm surprised they didn't call it Java something. But anyway,
the names change so regularly.
And the names change all the time. Sun Studio and
hey, look, it's new.
Java
4K. Anyway, won't pick on marketing too much. 2-drink minimum. Oh, I'm sorry. You end up with this big long name in the device path, right? So it's dev disk C0, T0, 16 letter hex thing.
Yes.
That's a real pain to deal with. Now,
yes.
That came from the worldwide number identifier for fiber channel, and then it got kind of inherited back. And I think even if you use SAS today with NPXIO, I think you still get this big, long, gnarly name. I'm afraid I don't have a good solution how to get out of that particular thing. I mean, there's ways and hackarounds you can make, but I don't know a good out-of-the-box solution for that. Cindy, are you aware of any? No, they just use the big long names. Yeah. Okay, over beers, I'll tell you a hackaround.
You're going to force me to take a camera into a bar. I don't know.
It doesn't have to be in a bar.
Oh, we're bringing the beers in here? Cool.
or something. We'll be creative. We're creative. But yeah, there are ways to get around it. But in general, kind of in an easy to maintain. If I get hit by a bus and somebody comes in and takes my job, it's going to be the big long names. Kind of unfortunate. One question back here.
Something that's we've come across just the simple usage and a major change we've been using both of ours ZFS is if, for example, you have a Z rule that has say 10 targets, and you want to expand it, you have 5 more disks, and those original 10 disks are strike. We haven't been able to extend the strike on the structure because the disks just start widening too far. Is that something that's changed, or is that something that we can talk about?
This is actually a performance question, right? And we're talking strikes, right?
Yeah.
Okay. And so what he's describing is, I've got 4 disks or 10 disks, and I've been using them for a while. And dynamic striping will kind of, in a round-robin fashion, use these disks, and they kind of get full. And then I add 5 more disks to the dynamic stripe. And the algorithm is designed such that it's going to try to balance that. However, the new disks you added have the most available space. So it's also biased to using the most available space. And so you could get an imbalance where ZFS is going to be trying to write new data to the 5 and not write it to the existing 10. Until such time as you start to become full. And then you'll get more of a round-robin balancing.
Then you're just pulling it, and you go from min to
Right, and then you're pulling and you add 5 more.
Yeah.
And you have this sort of issue.
So something like defrag utility that'll background balance that.
So today there's nothing that will go back and rebalance that. It's on the list of things to do. Because it is a very important and frequently asked question, although not quite in this manner as it asked, but the solution to this is the same solution as some of the other frequently asked questions about adding devices into a ZPool. Okay. And there is progress being made from what I understand. So where are we? It is about 3 o'clock. I'd like to take a break about 3. I don't know if that's when we're supposed to break or not. We'll take a little break about 3 for 20 or 30 minutes. And what topic do you want to hit before break? And keep in mind, the performance topic, that could be a whole day. So it may be that good one-on-one conversations or something like that would work on performance. There's a lot of people writing about performance as well, so we're trying to keep that information flowing. Yes.
So related to the performance, have there been any recent changes regarding how efficiently ZFS uses multi-core processors?
Yeah, so the question, how do we use multi-core? Actually, from day one, ZFS is designed to take advantage of multi-core processors. In the very early times, I would say longer than a year ago, actually longer than 2 years ago, we used a single task queue for compression. I believe it was compression, or is it checksums? Anyway, things like checksums and compressions we can do in parallel. And so all the modern releases, Solaris 10 Update 5, actually Update 4, and later, will take advantage of multiple processors for compression and checksums. Turns out that let me talk about checksums for a minute. So we have 3 different kinds of checksums. Did anybody know that? Do you guys know that we have 3 different kinds of checksums? 3 different checksum algorithms are available to you in ZFS. And by default, it's an algorithm we call Fletcher 2, which is a slight variation of Fletcher's algorithm. Metadata is done in Fletcher 4. And also you can set the checksum algorithm to be Fletcher 4. The Fletcher algorithms are better than a simple parity calculation or simple, A plus B equals C kind of a summation. They're better than those, but both of those are still what we would classify as a checksum algorithm. Right? So it's a mathematical, a fairly simple mathematical addition sort of a algorithm. You also have available SHA 256. Those are called digests, right? They don't call them checksums, they call them digests. So that's what the other option. Now, SHA 256 is an encryption quality, pretty darn good digest. The problem with the checksums is that, of course, there are, for 128K block, there are certain bit combinations that, in theory, could generate the same checksum. Right? In fact, there may be many, depending on exactly which checksum. In the digest, SHA 256, I don't think it's been mathematically proven, but they believe that there's not going to be very many combinations that will result in the same checksum for SHA 256. When we get down to dedupe, we'll talk about why that's important in more detail. But so we have SHA 256. Now, since it's more mathematically intensive, it will impact your performance in a negative way. On the other hand, if you're using a system like a Niagara-based, particularly a Niagara 2-based or Victoria Falls-based Sparks system, then we actually implement SHA 256 in the hardware, and it's really pretty darn quick. And it's parallel as well, so SHA on those kind of systems works better. On an x86 kind of platform, unless you have a cryptographic coprocessor, we'll have to use the main processor to calculate that, and it's going to be an impact you can feel, both on reads and write workloads.
So are these checksums only used for error detection or also for correction of errors?
Just detection.
Only detection.
Yeah. Okay, so you have those options available to you, and you could use them. And they will impact your performance one way or another, and then it gets into your hardware equation at that point in time as well. How are we on time? 5 minutes. Any other question related? Yes.
I was just going to ask if anyone has seen any problems with very long delays deleting Z-volume and Z-vols. We had an issue in May timeframe, which is the last time we had to do it, on a Thumper running Solaris 10 update 3, where deleting a 1 terabyte iSCSI Z-vol took an hour on the entire file system. The entire pool hung for an hour while this happened. It kind of caught us by surprise. We weren't really expecting this, so basically our file server was down for an hour during the day.
That's starting to.
Now this is old now, it's update 3, but it was...
Yeah, make a note, Cindy, because I know we did, we'll chase that down for you, because in the early days there wasn't a lot of people using Z-vols, and so there was a lot of things that we just kind of didn't know on Z-vols, and we implemented a bunch of bug fixes. I think that went into update 4, but for sure went into update 5 related to Z-vol performance, and that may be one of them that got fixed along the way. But we'll double check and see, because some workloads, particularly databases like Sybase that does raw devices, you would think of using a ZVol for that, and so when we started doing performance characterization on things like Sybase and Formix that use ZVols, then we discovered some things that were fixed since that time. So I want to say it was update 4 timeframe when some of those rolled out. I don't know if the subsequent ones have rolled out as well, but we'll track that down for you. Well, let's go ahead and take a little break then. And what do you guys think? 3:30? Is that good? We'll meet back 3:30.
Still trying to get the fish for you?
Yeah, let me see if I can do it. The RI-SCSI target isn't quite as robust as we'd like, and it's not ComStar based. I can tell you that today. That's in the foundation side. Then the other kind of bugs you have are the integration side, which means I took these 4 products and I put a new administrator shell on the front end of that, and I need to make sure that everything connects together and works and has documentation, and internal to Sun we have to train the service engineers right on how to use the product before it goes out and all this sort of stuff. So there's kind of 2 different kinds of bugs to look at there. And so the foundational bugs will be the same as you would find today in a modern open Solaris release. But the integration bugs should be largely fixed, I believe. And then, of course, there's a roadmap. And one of the things that's nice about an appliance model is that the upgrade procedure is very much more like a firmware upgrade. Now, behind the scenes, you'll know that we use ZFS clones to implement that firmware update. Right? So you'll be able to you'll understand then exactly how we're doing the magic behind the curtain. But that's the basis of the appliance. And we think it's going to be a heck of a lot easier to manage in that regard. So we'll see how our friends at EMC and HPA, NetApp, and Hitachi like it.
Is the Solaris interface actually accessible to you on these devices? We've got one of each of them coming. Well,
No, so if you do like an SSH to it, you'll be in a restricted shell. So you don't have full access, you don't have basically KSH or bash shell. It's got an appliance-oriented shell, which limits what you can do. So it's going to look a lot more like an appliance, to be honest. An awful lot more like an appliance. And the other thing about appliances that is good for the developer and good for the service guys is they restrict the number of possible permutations. All right, so we've already talked today. There's 10 levels of compression, right? There's 3 different checksums options. There's if I've got a 16-disk machine, there's 4,768,000 whatever possible permutations of making those disks redundant. Come on in, grab a chair.
Oh, I'm just going to listen to you.
Yeah. If you don't find a chair, we'll steal a chair for you. Okay, so in the appliance, then we can come in and say, look, we're only dealing with this hardware. I'm going to give you a couple of different options that are going to handle 80-95% of the type of workloads that we're going to see. And so basically, the complexity is lower, and so part of that is done by restricting the options that you have available to you. So, it's one of those things that, if you don't ask me any questions, I won't tell you any lies, right? So the fewer questions we ask, the easier things are to manage. So yeah, those of you maybe watching the release, it will be webcast and recorded so you can stream it later as well if you don't want to listen to me talk about this stuff. Okay, so I want to table any further performance discussions we can do later. And also in the appliance release today, it's a 7000 series system. We've done an awful lot of performance benchmarking on the system, and so there's nothing magic as far as we didn't implement new performance-oriented features for ZFS to get this stuff. So in theory, you should be able to, if you have the same sort of hardware configuration, get the same performance out of the box with the right configuration options for that. So a couple of words on capacity. The dynamic nature of ZFS means that the amount of available remaining space is somewhat difficult to determine in practical terms. And then with snapshots, as we talked about earlier today as well, we have snapshots consuming blocks and referring to older versions of files that you need to manage as well. And then we also talked about I can add disks to a pool and expand a pool. Okay, so there's a lot of things going on there. One thing that is not yet available, that's high on the list of things to do, it's definitely a frequently asked question, is rather than expanding capacity now, I want to remove capacity. Okay. In general, the size of the total available space of a pool doesn't get smaller. Right? It will always, you can add to it easily, but you can't really take away from that pool size. So that's a limitation, if you will, of today's implementation. So what that's led us to, or some of us to recommend that is a strategy we call grow into your storage. And that is, okay, suppose I have a thumper, I've got 48 disk drives in it, but today I only need 4 disk drives. And then next month I'm going to add a few more disk drives, and a few months after that. And by this time next year, maybe I'm using 30 of the 48 disk drives and so forth. And with ZFS, it's really easy to add those devices in as your storage needs. Now, we have a performance impact that we talked about earlier as well. If I'm getting up close to full and I add new empty disks, the empty disks are going to be preferred as far as where I'm going to put new data. So there will be this load balancing thing that will hopefully over time feel its way out. So we have those kind of issues in there as well. From a RAS perspective, I tell you, I really like this strategy. And the reason is the failure rates tend to be those things that we live with, right? So a failure rate for a disk drive, let's for the sake of argument say it's a 1% per year failure rate for disk drives, which is about what many of the vendors are going to quote. So if I have 100 disk drives, I'll expect 1 disk drive a year to fail. Okay, but if I only have 10 disk drives, maybe I won't get a disk drive failure this year. So in the RAS perspective, we really try to have fewer parts being in the operational sense at any given time, and then from a capacity perspective, I might need to add parts into my critical environment as time goes on. So again, another argument for growing into your storage. Kind of the takeaway from that is you have an option nowadays to think about how I'm going to plan for my capacity use over time. But there's multiple dimensions here. So we have the reliability, RAS perspective, we have a performance perspective, we have a systems management perspective, there's a backup perspective to all this as well. Okay, so those are all very different facets that enter into your design. So I encourage you to think about that and maybe think about using a grow into your storage kind of option. Now the people with big, huge data centers generating a lot of data, particularly HPC space, they have a harder task of this than I think than most folks. But if you have insights into that, if you can share or write a few good papers, or let us know how things are or what things work best for you. I think that would be a good thing for the community. Okay. Home servers. Is there a lot of interest in this topic other than how do I get something to work on 25 watts for $5.40? We see a lot of traffic on the forums that deal with people wanting to do home servers, and there's a huge variety of constraints and reasons and things you can do. It's a good topic over beers as well, but it's not really, that particular market is not driving our design. Right? We're being driven by people who need petabytes of storage and people who need big machines and need lots of disk storage and have computing power at their disposal. So home servers are interesting, but I don't really want to get into too much of that here. I think we beat snapshots and backups to death. I also talked a little bit about...
I have one question about backups. I'm just wondering, does anyone know if it's possible to back up iSCSI or actually any ZVol from the server side?
You mean like DD or?
Like back it out as a file.
Like DD?
Will that work?
Yeah.
Okay.
It is a device. It is blocks 0 through n. However, I want to, and you can snapshot them and all that. So, tar probably doesn't work very well.
It's a snapshot it and DD the snapshot.
Yep. Snapshot. Yeah.
I was just going to throw one comment about the home servers, although yeah, it's really cool to have all this stuff at home. One of the things that I'm using it for is prototyping, getting familiar with it before we put it on the expensive stuff.
Mm-hmm. Yeah. Oh, absolutely. In fact, any of us geeks probably have 5 or 6 or 7 or 8 or 10 machines in the basement, right, that we experiment with. And really my comment about that is on, if people say, well, I want it to run in 256 megabytes of RAM and be highly performant. And it's like, not a design target. Or they'll say, well, I want it to run, like a bat out of hell on a Celeron 1.2 gigahertz. Not something we're going to really target. The truth is, the cost of RAM, the speed of processors, especially in the home market, is, sometimes you'll just be happier, go to Fry, buy a new motherboard, spend $100, you'll be happy. Kind of an answer. I would say also in the home space, that's usually where we run into the people who want to get 2 gigabytes of space on a 1 gigabyte disk. We like to joke, they're porn collection, but it's probably MP3s or
also
pictures.
called DVAs.
Yeah, DVAs. So they're wanting to get a lot of stuff into, squeak out every possible last byte of that storage, and you're going to start making all kinds of trade-offs, right? You're going to do the RAID Z instead of mirroring. You're going to sacrifice some sort of performance or reliability. You won't even do data redundancy at all, right? And so again, that's something that we just don't really have time to work on as a target market. I guess that's an opportunity, right? So there's opportunities. Let me talk for a minute about clusters, and we already talked about HPC distributed clusters. Oh wait, question?
Just a quick backup question.
Uh-huh.
Sorry to interrupt. Is there any performance hit from having, like, say, 10 or 20 million files on ZFS file system for backing up, like you would get on UFS.
UFS falls over pretty good when you have lots of files. ZFS is much more tolerant of that. But we don't know the boundaries conditions. Now, usually the issue we run into when we're dealing with a lot of files, especially when we're reading attributes of those files, is the directory name lookup cache. Now, ZFS still uses the DNLC, and if you have a small memory machine, the DNLC is probably still going to be undersized, and it's a fixed size at boot cache. Okay, so usually what I would recommend is the first thing you do is we can look at DNLC stats to see what your hit rate is. You're always going to be missing until it's warm, but once it's warm, you should have a pretty decent hit rate. And it may be that we need to adjust the DNLC cache size, just like you would with UFS, if UFS could ever approach 20 million files, which I'm pretty sure it can't do in an effective way.
Kind of building on that, does ZFS still use inodes and have the same inode limitations as UFS does?
Okay, ZFS dynamically allocates, I think they're called dnodes, but yeah, the same sort of concept, but they're all dynamically allocated. In UFS, they were pre-allocated, and so that's why we kept running into troubles with UFS. And then when we went to multi-terabyte UFS, it became even more of an issue. But in ZFS, that's all dynamically allocated. So you should be able to have a huge, substantially huge number of files and effectively inodes, but we don't know the boundary conditions. We don't know the performance impacts at really huge numbers. We do know people with like 150 million files kind of range. Go get them, man. they're on the Wild West, and so it seems to function. But I don't really know how performant it will be. But my first concern would be DNLC.
Yeah, I've got one particular application that likes to put 3 million files in a single directory, and then they kind of complain when LS takes 5 minutes to finish. I'm like, it's just the way it's going to be, sorry.
Speaking of LS in large directories, LS by default will sort. Okay. Sorting 3 million things will hurt. So you might want to pay attention to options if you want to do an LS, as an example.
Yeah, they normally don't use LS for that. And they also have character names that are over, what was the limit, 32 characters or something like that. So it doesn't even get in the DNLC.
Right.
So it's not even cached. And then they have problems when it takes a while to go find the file and actually read it back from disk, and the database chokes because of that.
Yes. Okay, so there's all kinds of pain that they're
Yes, yeah, there's a lot of problems. We've discussed it. I've beaten that dead horse a lot with them, and they're fixing it. It didn't start out that way, obviously.
Never does.
No.
And sometimes it's do you change the most significant bit or the least significant bit? It makes a huge difference in our sorting and stuff. So that's going to be a problem when you're talking large, huge quantities of files. I would ask though, for those of you who have huge quantities of files and stuff, let us know how it works. And if you're having, like this LS issue, talk to us about it, because although it sounds like you hit all the immediate bullet points, there may be some things that we can do to help. Now, the basic structure of ZFS is fairly efficient in dealing with those large. In other words, we don't do a linear scan.
Yeah, this is actually the XFS file system. We haven't put ZFS on there yet.
But we don't know if there's other things in there that we could possibly help you with, but it's just not something that we normally run into.
Yeah, not too many customers are going to be able to test that, but
or
run across it, well, we should have mentioned it.
It hurts when you do that, don't do that, right? Yeah. Any other questions? Oh, I got a couple over here.
I would like to discuss how the ZFS file system handles physical disk failures. Because I had an instance where I had a disk array, and in the first instance I exported all the disks as JBods, and I let ZFS handle this. And this was sort of the first releases of ZFS file system. And I didn't have a pleasant experiences with this. I mean, the disk failed and it wasn't discovered properly, and the whole server was slowing down to a grind. And then we decided that maybe we should let the hardware to manage all these disks. And that's what we've done. So all I'm asking is whether there's been any improvements in that area recently, or
there's been a lot of improvements. And I earlier talked about the fault management architecture and how that impacts. So disks actually have a large number of failure modes, and in the case of a general purpose operating system like Solaris, there's an awful lot of different things that can happen, and there's a huge myriad of hardware running around out there. So for the systems that Sun makes and the hardware that we use, we have a lot of extra testing on it. Some of the others we don't. And so for the vast majority of disk failures that we do test for, the failures occur fairly quickly. However, in real life, we do know that there are devices that don't necessarily fall into that category. And those are going to be troublesome. And it could be that you'll trip over one of those, as the case may be. Now, my next question would be is, which OS version were you on? Were you on Solaris 10?
Yes, Solaris 10 update. 2 or 3, I think it was there.
Okay, and we've made a lot of progress since then in this particular space. But there are still some, I've got a disk, for example, that will hang a SATA controller, but not all the time. So it's a lot of fun to test with when I'm feeling particularly interested in bashing my head against the brick wall. But it's one of those things that how that is handled can vary. It has varied over the years as we've added more intelligence into the fault management architecture. So my expectation is today you're not going to see that same sort of thing. Now,
especially if you use the Sun kit, because we use Sun disk array and Sun server, so a bit better tested than if you use.
Yeah, we do test them. That's part of our standard automated test structure. We have all of our gear. Right, I mean, because that's what we use the same hardware for hardware testing as well as software testing, so that makes sense for us. There are some interesting trade-offs there, though, and that is timeouts. Like I said, ZFS doesn't do disk timeouts. It relies on the underlying storage device to do that. So the way it's written today, the first time ZFS does an I/O to a device block, or block at a device, then it's going to set what we call the fail-fast flag, which basically tells the device driver, hey, if anything goes wrong, let me know quickly. And that seems to be helping quite a bit in the response time for failures. Now, the device driver itself is responsible for all these timeouts and retries. So the scheduled device driver, SD, or the serial scheduled device driver, SSD, which incidentally share the same source code, also have device retry logic in them. And the default retries are one retry every 60 seconds, and either 3 or 5 retries, and then we fail it. Okay, so you will think into your mind, you'll say, gosh, 5 minutes seems to be a long time to wait.
66 is a long time.
And some people would say 60 seconds is a long time. So we argue about these settings, and they are tunable. Okay, so that's good to know. They are tunable. But we have certain constraints because we are developing to a generic platform. And one of the constraints is on a SCSI device driver. We use the SCSI driver to access CD-ROMs in older SPARC machines. Okay? So is 60 seconds an appropriate timeout for a CD to spin up and to seek and return data? And I'm not talking by 4 CDs or by 4, I'm talking like by 1 CD, like the slowest ancient 12-year-old CDs. And the answer is, well, 60 seconds is actually probably about what you want. Wait for that. So the SD driver then by default has a 60-second retry timer. So is that tunable? Yes, it is. Would you like to tune it? In some cases, yes, it would be good to tune. But the reason we don't generally recommend that is because the other thing that people are really interested in dealing with today is power management. Okay, so now they're powering down disks. Okay, so how long does it take for a disk to power on, spin up, and return data?
45 seconds.
Yeah, between 15 and 45 seconds, I would say, for the most part. And so we're like, okay, so if we make a general recommendation, we change it to 30, okay, maybe we're on the edge there. Then we discovered that some HBAs, who shall remain nameless, will only issue a power up in sequence. So now it's not really a matter of me asking the disk through the device driver to power up. Now it's got to go through the HBA who's going to sequence all these disks to spin up. And so that could take more than a minute. So the net of all that is, okay, there are timeouts there. There are retry counts you can tune. There are timeouts you can tune. I would caution that you do this only if you understand your entire system and how it's designed and what your expectation is for that hardware. And then you can improve some of that logic. So where we try to make it faster, like with the fail-fast options and with the FMA, and doing some prediction kinds of things, we're trying, but it's going to take us a little while to get more of that integrated into the system. Yes?
So kind of related to that, I've seen instances where when you do Z-full status, it'll list a disk as cannot open, but it never fails in a hot spare for it. So I'm wondering, is this...
And which OS release is it? 10?
I've seen, yeah, Solaris 10, like update 3, update 4.
Okay.
Seen both of those.
So part of what fell out of that is, while we were waiting on the FMA stuff to be baked into the product, the logic for just determining that a system is dead or a device is dead and then kicking in the hot spares was really very basic and didn't work particularly well because there was a lot of failure modes that it didn't cover. And so again, with the update 6 with Open Solaris, it's much more sophisticated about how it detects that a device is dead and when it kicks in the hot spare logic as well. And earlier I talked about auto replace, right? We were talking about auto replacement. The auto replacement logic kicks in as well. So we have spares, we have automatic replacements going on. And so it's a lot more sophisticated in update 6 and later versions than it has been. So those kind of features are coming in. We still have a few to go yet, though, I think, and some that we don't quite yet have identified, in my opinion, that we'll get to. But update 6 is going to be a lot better than the previous ones for a lot of reasons. Yes?
Do you get the same functionality by patching, or do you have to do installation of that these days?
As far as I know, there's not a patch that delivers this, but I don't know what's going to happen in that regard.
That's what I'm playing with over here. There's some of the readmes kind of give a list. I can show you the patch number in the readme. I got it out of later, but it says if you want to have all the features of ZFS boot on Spark, download 6 or 8 patches or so, and they got a list of patches to include. Whether or not it actually works, we'll find out here maybe in a half an hour or so.
I love real-time discovery. Yes.
Can you explain how the faulty disk detection is working?
How the prediction is working?
The detection. So you will respin of the drive,
in general,
shut down and spin up.
In general, we won't. A lot of that's handled by the lower level drivers. So SD, for example, has retry logic that may send a SCSI reset.
Oh, yes, SCSI reset.
For example, to a SCSI device. So it may send a reset to a SCSI device. In the past, that would have been something we did a lot. When we start to share storage between multiple systems like we do in a high availability cluster, then we kind of prefer to try not to do resets if we can on the shared side, because some of the reset logic in disk drives, and it's not a bad problem with RAID arrays, but with disk drives it would cause the other host to also retry if the other host was active. So there's different ways that we try to approach that, but most of that's going to be down on the driver level, and it will depend on which driver is actually in operation there. CMDK or IDE, NVSATA, and so forth. So there isn't really a generic answer I can give, especially from a purely ZFS perspective, because it won't see those. At one time, I had a big, long document that talked about the SCSI failure modes and retry logic. It's an internal document, but I think maybe that's something. Cindy, would you make a note for our troubleshooting purposes? See if we can dust off a version of that is suitable for external consumption. Because I think, well, there's also a lot of code back there that seems to be like magic. SD driver is, I don't know what, 75,000 lines of code or something like that. So it's not something that the casual person can go understand.
It's been around for a while.
It's been around. It's been heavily modified many times. And every time I think I understand it, then they change it. Yes?
You mentioned fault prediction. Is that done differently than the, well, it is obviously done different from the detection, but is that something that ZFS just also passes down to the low-level driver, or is it trying to do something else?
In the predictions, like the smart kind of predictions, right now the plan is, and in fact some of the implementation has been done in the FMA modules. Okay, so I haven't gone digging into that to look exactly what they do, but things like the predictive failure stuff. Now, in theory, the idea was with Smart that we could start to see evidence of a failure for a hard drive before it happens. In practice, the data really doesn't show that. They tend to just freaking fail. And so, you know, it's those of us in the reliability world, we're like, yeah, okay, it's better than nothing, but not much better than nothing. So I'm not real hopeful that we'll have a whole lot of predictive failure stuff for magnetic disk drives. I have a higher confidence with solid state, mainly because I'm a chip guy and I understand solid state a little bit. But solid state fails in a slightly, or actually many different ways, and so those have a better chance of being predicted. But all that logic is going to be in an FMA module. And the source code for the FMA modules is also open, so you can go check those out if you'd like. All right, anything else, or shall we move on? Next topic. Did I ever talk about clusters? Let's talk about clusters for a minute. In the scheme of HA clusters, in an HA cluster, it's very important that only one node writes to ZFS at a given time. Okay. So in Sun Cluster or Solaris Cluster, what we do is we actually will import only on one node in the cluster at a time, and then everybody else would access that disk through, or that file system, or the pool actually, through that one node. There's a failure mode that can occur where two nodes have imported the pool simultaneously. Okay, this doesn't tend to happen in the Sun cluster today, because in Sun cluster we actually use SCSI reservations and fence off the disk. So only the node that has rights to access the disk can also get to it through SCSI reservations. Okay, that's pretty safe. Now then, there's a change coming in the Solaris cluster due to popular demand to make SCSI reservations of data disks optional. And it is with mixed feelings that we allow this to happen. But basically, the problem we run into is that some devices don't implement SCSI reservations very well, and some devices like SATA drives don't implement them at all. But you still might want to use those in the cluster. So rather than fight the tide, we're changing it so that can occur. So there is a failure mode then, as system administrators, you might want to be aware of, particularly if you use SANs or iSCSI devices. If I have two machines import the pool simultaneously, eventually one or both of them will panic, and it's not likely that you'll be able to recover the data. Okay, because it's going to mess with metadata, and once you blow out your metadata, it's game over. So be particularly cautious of those situations. Multiple systems importing pools at the same time. Okay, so now I scared the hell out of you. Update or Solaris 10 and old Nevada releases. There was not a way in the pool metadata to tell who was importing me. Okay. Today there is. So for later releases, I want to say this hit somewhere around build 70. There's a host ID that's recorded in the metadata for the pool. Okay. So basically, if I'm importing a pool, it'll write my host ID into the metadata for the pool, and then if the other node tries to import it, it'll look at that host ID and say they won't match, and it'll say, hey, looks like somebody else has this thing imported. You'll have to use the -F flag to import. Okay, so what do? Human nature says the next thing you try is import -F. Rather than, hey, is anybody actually using this?
Everybody loves the -F flag.
Okay, so there is a -F flag there. Because there are times, again, back into a cluster environment, if the other node dies, then I want to force import that pool. Okay, so it is something we would want to do proactive, and so the -F flag is there. But it does open you up to this case where I have let's say a shared iSCSI target. I have two nodes importing the pool. One guy will do a -F, and then we lose the whole thing. So that's one to watch out for. You'll also see it in a number of failure modes with having to do with, in build 100 or 101, the host ID is now an ETC, a file in ETC. And therefore it can change. And therefore your root pool may not be owned by you according to ZFS, which means you can't import the root pool boot, which is a bad situation to get into. So, if I'm not mistaken, we're documenting that, right? And it's.
That's just an open Solaris, right?
Yes. Yes. So there are some things that you'll see this mode. It'll say, it looks like this pool is imported by another host, and that's, that should ring a bell. Hey, ding ding ding. I need to deal with. Did I intend that or not? Do I need to -F it?
Imagine the look on my face when.
What do I need to do? And if you're doing upgrades from like build 97 to build 100 or 101, this may trip you up as well as your host ID changes. No question.
Where does the host ID get generated from? So I ran into that with the VM on here when I was trying to get the VirtualBox thing running, and it's not, the networking isn't starting up, so it comes up with host unknown, and that doesn't match the name. Or something didn't match.
Okay, so
it didn't import the data pool that I created.
Yeah. Okay. So the host ID is an 8-byte hexadecimal. We think of them in hexadecimal numbers. In the Spark world, we write those into we open boot prom when the machine leaves the factory. And so, we got this database that said this machine went out to this customer, it's got this host ID. Okay? That worked fine until about 1998, when we came out with the Starfire machine, which is a multi-domain host. So now that pieces of that machine may actually be subdivided, and then you need a different host ID for each instance of Solaris, and so we had to fake how that happened, and then we started losing track. And then in the x86 space, there is no open boot prom. And if we go off and tell all the BIOS vendors to start implementing this sort of thing, then nuclear bombs go off and bad things happen. So in this x86 space, it's actually in source code you can look at online in the kernel what they generate. They basically randomly generate a host ID number. And then it stays persistent. They used to hide it, right? So they used to say, well, when you installed Solaris, we randomly generated this host ID number, and then we squirreled it away for you. The change we made in build 101 is now it's an ETC file. There's an ETC host ID file that has the host ID in it. Now then, there's some independent software vendors who use the host ID for software licensing purposes.
Wink, wink.
Now, ever since day one, host ID has been spoofable. So I would suggest to you, if you're an independent software vendor and you don't trust your customers and you need to have a host ID license key thing, then you ought to trust your customers. Especially since, it's a kernel thing. Even back in the SunOS 2 and 3 days, we compiled the kernel. Well, hello. I'll just rewrite the host ID code, right? So it's been spoofable forever and really doesn't do much. So we use it in this case, a ZFS, at least to have some method of trying to get you from having two hosts simultaneously import the pool. But it's not very sophisticated. And then in Open Solaris, we finally threw out the gauntlet and said, okay, it's an ETC host ID. And then, it's also scrambled. But it's scrambled using Perl TR, and it's in the source code. So if you do a source opensolaris.org, you do a source on it's the host ID, and you'll see the code. Anyway, so host ID, and that's why it's there. So the idea that, Chuck was talking about earlier about how he wanted a simple cluster failover that isn't as heavyweight, if you will, as Solaris Cluster, is very possible with this. So we have, in other words, we're using the host ID and the Z pool as a way to help manage two hosts trying to import the pool at the same time. It's a very important thing for an HA cluster. The Solaris Cluster world has a much larger problem space. Right? We deal with a lot of different hardware, we deal with a lot of different features, and we even go back to Solaris 8, which doesn't have some of these nice cool features. So it is pretty heavyweight, and the aforementioned storage appliance announced today has plans to implement a cluster, basically a head failover for the storage heads, and it will not use Solaris Cluster. It's going to use a system based on this lighter weight thing. Again, since we have a reduced scope problem area, we can do that fairly efficiently, very easy to administer using this host ID awareness feature. But I assure you, as a system administrator, you're going to trip over this. At some point in your life, you're going to have a host, can't import the pool because of the host ID, blah, 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 use -F, and so on. So be watchful for that.
So that's mainly on cluster machines, or are we going to see that on standalones somehow?
You might see it on standalones. I don't worry about it.
Yeah.
On my standalone machine, I know what's going on, typically. Yes?
Given that I just saw it on this virtual instance, if it's just the data volume, I suppose I can manually force it like I did doing here, but
right.
If it decides to change its ID of the host ID and the root volume, it sounds like the root pool, it sounds like you're really hosed.
Yeah, so I think the workaround, Cindy, you'll correct me if I'm wrong, is you boot someplace like a failsafe